Hello, my name is Andres Flores, and this is also Andres Trujillo. And our group, the Double A's, have teamed up to present to y'all our latest and greatest design, a robot. A robot that not only can be able to go through any obstacle course known to man, but also one that is able to withstand any extreme conditions put to its test. For this competition, we're having to put our robot built by us in an incarcerated shallow path, and we will see how well our robot is able to withstand this obstacle course. And Andres is going to talk about its problems that we face and solutions that we have to it.
Well, first of all, we can start talking about the ultrasonic sensor. It was an issue to calibrate it in order for it to get into the black lines and have its way through. We also had a few issues making sure that the wheels go the right way, which was a weird thing that it wasn't working as well. But as well, we also focused a lot on the ultrasonic sensor and the code to make sure that it went the right way and that it avoid all the obstacles that needed to be. We also made a little sketch where we did kind of like a small size version of what the actual competition would be. And so we should be good and get it ready get it started off.
Of course. And like he said, the problems that we face with this robot, we built our own mini track just to be prepared. As the recording of this video, we haven't actually got to go out and take it to the real test, as other groups probably have had that ability to. So, we're kind of on the lower edge, ideally, but, due to the sensor not wanting to read with the black line, we tested it quite a lot in different scenarios, made it darker areas, different materials to see what the robot was struggling with. We kind of came to a conclusion of maybe it's a faulty sensor. We don't know just yet, but our main goal is just to be able to get through this obstacle course with ease and perfection. And so just trying to perfect the sensors from the robot itself is ideally what we need to do first. And of course, another thing is the code itself, writing it and being able to pinpoint each little movement of the wheels, backtrack, and all, etc. But after all these tests personally done by our mini main personal track, we have actually still been able to see that the response and speed of this robot is going to be hard to beat. As let's see right here, the robot is able to respond immediately as soon as turned on and instructed to go. We're aware that the code is also dealing related to winning, as the code could be the deal breaker in some senses.
A lot of people focus more on the coding more than just the actual robot itself. What's amazing about it is that the basic, you can do as basic as a code and get it straight through, but you can do a lot of lines of coding, making sure that every centimeter is right. But we kind of just went straight forward with our coding. We just wanted it to go through some obstacles, and at the end kind of just made it through the black lines. Just the tracking and the obstacles are the main part of this robot that makes itself. Another thing that kind of was impressive to me is just how many stuff it takes just to make this itself. You got sensors, you got board and cable, just the basic cables, modules. Another awesome thing is that you can actually control this with your phone. That's a really good thing to do. Just on your phone, you can do it on your remote. But on the competition itself, we're gonna use our main. We're gonna use our phone just to set up in the field and just make it go with our coding that we have set up for that.
Yeah, and as time passes, efficiency is key, as keeping a charged battery is probably the best thing, and preserving that battery the most we can will allow it to keep that speed as high as possible, and as having the most electricity, or I guess power, available to the robot will be the key or one of the keys to its fully success. But that is Double A's, and we're signing out.